Good morning, ladies and gentlemen. Welcome back to Earth Science. We are starting a whole new chapter today. We've just finished chapter 3, which is rocks. We are now moving on to chapter 4, Earth's geography, and covering these two subjects, landforms and maps. So let's start today with landforms. Before we even begin to go over the lecture on landforms, I'm going to give you the following activity that will help you become familiar with some of these amazing landforms. You may have had the opportunity to visit some of these places, and if not, you might not even be aware that they even exist. As you go through this course, you should start to understand the concepts behind the formation of these landforms. So the link is found here, or it will be on your student's Google Classroom, and it will be this lab here. You will be exploring North and South America's landforms and their locations. Using a provided map of North and South America, you're going to explore those two continents and find specific landforms and locations. Your job is to find these 25 locations. You're going to be placing dots, circling, outlining, labeling, etc. different landforms in North and South America found and will be populated on this map that will be printed and provided for you, and this map. You will document both of these maps with all 25 of these landforms and will turn it in as a grade. That will be your first assignment for chapter 4. When we finish this, we will move on to the lecture. Now, for those who are absent, you will need to print that lab out and populate it, or click here, either one, and print it and populate it with the provided landforms, informing, highlighting, circling, coloring. Make it very well identified. I like to use color, so coloring pencils or crayons. Permanent markers aren't a good idea. They bleed through both sides of maps unless you have a one-sided paper, not double-sided. And indicate with color preferred these particular landforms, especially larger areas, outlining them, the river basins, etc. It makes it really easy to see and grade. Okay, so let's go ahead and move on. That is what you will do for those who are absent. Once you have completed that, we're going to continue on. I would ask you guys to click on this link. It says Awesome Landforms of North and South America. This will give you some of the visuals and better explanations of the following landforms that you were hunting for earlier in the lab 4.1. So this is a really good link there. I'll let you guys click on that. There are many, many more landforms in North and South America than what I asked you to find. There are thousands more across the globe. Some of these general landforms we will discuss in this chapter. And those ones that can be generalized and encompass a majority of those landforms are these here: mountains, plains, and plateaus. You will want to write these down and provided within each of those specific landform generic groups, definitions, examples, and drawings. So leave space for each one of these. And this is an example of mountains, plains, and plateaus. Let's talk about plains right off the bat. Plains are very large and fairly flat areas. That's a general definition. Okay. Now, if you find them near oceans, they're called something a little different. There's an added word called coastal plains. Coastal plains can also be referred to as lowlands, so keep those synonymous together. Now, back to plains. Plains contain low rolling hills, swamps, and marshes. Write that down. If you don't know what marshes are grassy wetlands. that are usually flooded with water. This is an example of a flooded coastal plain, excuse me, as a reference. Wetlands are different than swamps, though, okay? Right here. These are different. This is mud-based, this is grass-based, okay? Lowlands, they're usually at an elevation of 0 or below. It's important to know because they're almost always flooded. If you don't already know, remind yourself what is the definition of elevation. Elevation is the distance above or below sea level, depending on where you're at. You can be in the interior of a continent and still be below sea level. So make sure you're aware of that. There are two major coastal plains in the United States. There's the Gulf Coast and the Atlantic coastal plains. You'll have to find these on your map if you hadn't already. You'll understand this now. That's like, for example, the Florida Everglades would be part of this piece here. Okay, other types of plains found in the center of land masses are called interior plains. These two also contain low rolling hills and are many times filled with tall grasses and shrubs. It may not be flooded, but it is still filled with tall grasses and shrubs. And in the USA, we have an interior plain called the Great Plains. That is probably the most important piece to the United States, better known as the breadbasket of the world. It provides the majority of the grain that we consume and export. It's very important to us, extremely important, and it is an interior plain. And it encompasses the Great Lakes, Central Lowlands, Missouri, Mississippi rivers, etc. Those are all part of that. Just make sure you're aware of that. And it is a flat plain, primarily flat, some small rolling hills, primarily because it once was a shallow sea. And it is filled in with a variety of sediments from the erosions of the Rockies, plus from the accumulation of bioorganic material. So the Great Plains contain sands, silts, clays, bioorganics such as limestone, which is part of calcium from the decaying or dead matter of fish or shells like crustaceans and bivalves, etc. All of those contributed to the creation of limestone. And then on top of that, there's kind of the whipped cream on top of the pie. It also had a bunch of glacial till from the previous ice age that had brought forth so much glaciation all the way to the midwestern point of the United States, very low, and it had crushed a lot of rock. Ice grinds up rock, and when you have a mile thick flows of ice, and the ice retreated from the last ice age, leaving behind a bunch of small powder-like sediments of different rocks that were crushed to powder, and that also was blown in and distributed over all of the Midwest, or the big Great Plains, which basically supercharged the soil, making it the best soil in the world to grow. Very important piece to us in the United States. That's a little bit of a rant there, but very important. The second one is plateaus. Plateaus are a large, relatively flat, and raised rock from the surrounding native rock. It's called a plateau. Uplift is a primary reason why we have this. There are three types of plateaus in the U.S. We have the Colorado, we have the Ozark, and we have the Appalachian. This is an example of a Colorado Plateau in which we live on now, for those who live here in Taylor, Arizona. And Snowflake. We live about right here. Arizona is not all desert, as we understand where we live at now. We live on the Colorado Plateau, a raised uplift that's also what created the Grand Canyon, ladies and gentlemen, as we've discussed in earlier sections and watched a tutorial on how that was created, or documentation, excuse me. And when you drive down towards the valley from where we live, you drive down the Mogollon Rim, you are actually driving off the edge of the Colorado Plateau, leaving it. That's why it is such high. It's such a high elevation where we live versus down in the valley. There's a roughly 5,000 foot or a mile difference in elevation from us to the valley due to this uplift. The third one is mountains. They are landforms that rise high above the ocean and make up, I believe, some of the prettiest places on Earth. You also need to note that the highest peak in the U.S. is Mount McKinley, found in Alaska, and Mount Everest is the highest in the world, found in the Himalayas. This is a picture of the Himalayas. Beautiful, beautiful. Now, with mountains, there are 4 types. This is where the material you need to get into is. There's folded, upwarped, fault block, and volcanic. I want you to draw these. This is important to draw because it helps you visualize what you're going to be looking at later on in future labs and exams. If you see this first one, upwarped, this is caused, or this upwarping, I'll actually give definitions further down here, but notice how this is a perfect curve. This one tries to formulate or follow that curvature, but it has to fracture to do so. We'll talk about that. Volcanic mountains, fault block mountains. This is the diagram here. Understand these arrows. This indicates movement of large blocks in certain directions. Very important. And folded mountain complexes due to compressional forces on both sides squeezing the rock. Like putting a piece of paper in your hands and pushing it together, it will make these loops here. Okay, let's give you definitions on that. Folded mountains, starting with this one down here. They occur when rocks are squeezed and begin to buckle and fold. The Appalachian Mountains are an example of these type of folds. Okay, Appalachian Mountains are the mountains on the eastern coast of the United States. Very old mountain complex. They were folded between 250 and 300 million years ago. They are also the oldest mountains found in the U.S. They were actually taller than the Rockies now at one point. But because they are no longer being built or being uplifted, erosion is wearing down those mountains. They're very, very hardened granitic and gneissic rock, so they don't weather as fast. But over the last 250 million years, it's taken quite a beating, and it's weathered away 3/4 of the mountain. Now, understand that it has to do with compressional forces that create these, and also note that these folds, they have names to them. The high point is called an anticline. So it looks like an A, yeah? An anticline is this up here, also noted right here. In this picture, you can see the fold going down and up and, going up and down and up. The high point is an anticline. The low point is a syncline. So this low point here as well is a syncline. Make sure you know what those are. It's the bottom part of the fold is a syncline. The upper part of the fold is considered an anticline. Beautiful picture, by the way, of seeing folded mountain complex. It's beautiful. Upwarp mountains, the one that we looked at up here, this fracturing matching a curvature, it has to do with sedimentary rock on the surface that is getting pushed from underneath by an igneous or metamorphic rock due to tectonic forces or just erosion and uplift. And you have a massive chunk of igneous or metamorphic rock pushing underneath the crust, causing the crust to bow, but being that the crust is rigid, it won't just bend to the curve. it has to fracture in multiple pieces in order to match that curvature. Does that make sense? And because igneous rocks and metamorphic rocks, they weather differently, they are stronger and they have more ability to push through that crust, causing it to fracture rather than itself. And when it reaches the surface and creates a mountain out of it, it doesn't weather as fast. That's why the Appalachians are still there. This is a picture of the Adriatic Mountains in New York. It is an upward mountain. Fault block mountains is my favorite. Think of dominoes that you've stacked up and you've pushed over. Between each domino is a fault line between them, and each domino is a fault block. And once you push it over, it slides halfway down the back side of the one in front of it. That is how it looks. You have a higher point and a lower point, kind of a zigzag pattern. So it starts high, zigzags down, up, down, up, down, up, down. The high point is called, as you see up here, is called a horst, and the low point is called a graben. Okay? Horst means horse in German, and graben means grave in German. So the low point and high point. So basically you have fault blocks, or an example I should say is you put your hands together like you're praying, tilt it sideways, maybe about 20 to 30 degrees, and then slide your hands apart. That is what a block or a large block of rock is doing. It is sliding down a fault away from each other, making one side of the fault higher, the other part lower. That's the high point or the mountains, and the low point is a valley. This is an example. That's an example of it. So basically, fault blocks sliding down. It's really what that means. An example of fault blocks would be the Grand Tetons, as shown here in Wyoming. And also from pretty much the Wasatch Mountains in Utah that border Salt Lake City on the east, all the way through Nevada. Every one of those are caused by what's called extension. It's being pulled apart, and so you hit this domino effect or stretch mark look of multiple linear parallel mountains caused by the from the fault blocks slipping along those along the crust, fracturing and thinning, making high points and low points. And last is volcanic mountains. They're formed when molten material reaches the surface through weak areas of the crust. That's pretty simple, self-explanatory. A volcano erupts, material piles up layer upon layer until it makes a cone. That's a very indicative mountain of volcanic mountain. Okay, that's a picture of Mount Areno in Costa Rica. They also note that they can grow, grow and shrink in a relatively small amount of time compared to other mountains because they can weather fast. They're not really well cemented, and so they can be wiped out pretty quick with erosion. Okay, that's it, ladies and gentlemen. Once you've gotten this down, you will click on this link, types of mountains or other landforms, or go to your Google Classroom, and I'll have it open. You will open up this. What you are going to do is get into groups, and you're going to have groups of 3 or 4. Choose a group leader, which will be the tallest person in your group. That individual will create a Google spreadsheet. This is a Google Doc. You need to create a Google spreadsheet. And on that spreadsheet, you will do the following. And I'll pull up a spreadsheet to give you an example. So you'll have a Google spreadsheet, you'll click on one, you'll open it up, you'll take this document, this information right here, you'll copy this info, and you can actually paste it into your Google spreadsheet, and then start working from here. It's easier. You can expand it, change it as you need. what I want you to do is get familiar with how to use Google Spreadsheets again. Get some practice with it. Your job is to do the following. As a group leader, you will share this document, which is a Google spreadsheet that will have all of your names. It will say chapter 4.1. I want you to type it up here. All your names and your hour. And all of you will work on a portion of these. The group leader will assign one or two sections or one or two landform types, and you will all research examples and locations and where they are at, as it says right here. You will also define / explain them, which means give me some geologic history about it. What is the landform? How is it formed? And then you're going to populate it with an image as well of those two landforms located here. You will populate it. This is where you will populate, and you will submit this back to me. Any questions regarding that? Okay, that is your job, ladies and gentlemen. Let's get going.